WPR 11. So when solving an equation with exponentials on both sides, we're trying to get the bases to be the same. In this problem, 16 and 64 can both be written as a base of 2 or 4. I like 2. 16 is 2 to the power of 4. And 64 is 2 to the power of 6. This is called raising a power to a power, and I need to multiply these exponents. So this would become 2 to the power of 8x plus 12 equals 2 to the power of 6x plus 12. Well, the only way that the two sides of this equation can be equal is if these exponents are the same, since the bases are the same. So I'm allowed to omit those bases and solve the equation 8x plus 12 equals 6x plus 12. If I subtract 6x from both sides and subtract 12 from both sides and divide by 2, I would get 0, which is a strange answer, but it is correct. To find g of f of negative 3, first I need to find f of negative 3. That would be found by replacing the x in f of x with negative 3. So instead of x squared minus 6, it would be negative 3 squared minus 6, or 9 minus 6, which is 3. Now I need to take that value and put it into g. So I'm finding g of 3, or 2 to the 3 minus 1, or 8 minus 1, which is 7. Because in the denominator there's an exponent of negative 2, I need to take that entire expression, move it to the numerator, and make the exponent positive. Now I can remove that exponent of 2 by squaring everything on the inside. Well, 2 squared is 2 times 2 is 4. X cubed squared 3 times 2 is 6. Y to the negative 7 squared, negative 7 times 2 is negative 14. Now I can multiply the 3 by the 4, and this x to the negative 4 goes to the denominator to make the exponent positive. The y to the 5th stays where it is. The x to the 6th stays where it is, and the y to the 14th goes to the bottom so that the exponent can be made positive. Let me compare the x's. 6 minus 4 is 2, so in the numerator I have x squared. 5 minus 14 is negative 9. But I can take that y to the negative 9 and write it in the denominator as y to the power of positive 9. Before I factor this, I need to write it in standard form. This is a tricky trinomial. 12 times 5 is 60, and so the 12x squared stays the same, but I'm going to take the negative 19x and rewrite it with a negative 4x and a negative 15x. Then from the first two terms, I can factor out a 4x. I'll be left with 3x minus 1. And from the second two terms, I can factor out a negative 5. And again, I'll be left with 3x minus 1. So from each of these, I have a GCF of 3x minus 1. And when I factor the 3x minus 1 out of this, I'm left with 4x. And when I factor a 3x minus 1 out of this, I'm left with a minus 5. 3x minus 1 times 4x minus 5, or 4x minus 5 times 3x minus 1 is the answer. Using a tricky trinomial, I can rewrite this, and I can take the negative 13x squared and break it up into a negative 9x squared and a negative 4x squared. Factoring the first two terms, and the next two terms, I see that there is a GCF of x squared minus 9. And now I can set each of these equal to 0. To get plus or minus 2 and plus or minus 3. To solve the radical equation, I will square both sides. And I'll get x squared equals x plus 6. It's quadratic. I'll get all the terms on the same side. Factor. Set each factor equal to 0. And solve. Three doesn't check. Negative 2 is the answer. When you have a log on both sides, cancel. And now I have a quadratic. Get all the terms on the same side. Factor. Set each factor equal to 0. And solve. Plus or minus 3. Let's replace secant with x. And now we can put this in standard form. Factor. Set each factor equal to 0. Replace with secant. Secant theta is 1 over cosine, so if secant theta is 4, cosine of theta would be 1 over 4. If secant theta is negative 2, cosine of theta would be negative 1 over 2. Using the half, we can get a reference angle of 60 degrees. Cosine is a half at 60, and it's negative in quadrant 2. 180 minus 60 is 120. And quadrant 3, 180 plus 60 is 240. We'd have to use our calculator to get our reference angle here. Inverse cosine of 1/4. It asks us to round it to the nearest degree. And 1/4 is positive, so let's go into quadrant 1 where cosine is positive, and quadrant 4 would be 360 minus 76, or 284. So it looks like my answers from smallest to largest would be 76, 120, 240, and 284 degrees. To receive full credit, you need to make sure your rounding is correct. Also make sure you write the equation. So y equals there's the correct equation. The year 2000 would be replaced with 15. And if I evaluate this, we would get 10,707.5. First, I can see that I have a side with an angle across from it. Using this side, I can then find the angle across from that. When you use side angle pairs, that's the law of sines. So 12 over sine of 32 degrees is equal to 10 over sine of x. That would mean that 12 sine of x equals 10 sine of 32 degrees. If I divide by 12, sine of x equals 10 sine 32 degrees divided by 12. Using my calculator, I can calculate inverse sine 10 sine 32 over 12. rounded to the nearest tenth, it would be 26.2. So I now know that this angle, B, is 26.2 degrees. Subtracting 26.2 from 180 and subtracting 32 from that, I can figure out that angle C is 121.8 degrees. Now I know all the angles. I'm asked to find all the angles and all the sides, so I can use the law of sines again to find side C. It's across from angle C. So C divided by the sine of 121.8 is equal to, and I'll use 12 and sine 32, but you could have used the other angle side pair. But anyway, cross multiplying, C sine 32 equals 12 sine of 121.8, or C equals 12 sine 121.8 degrees divided by sine 32 degrees. If I find this to the nearest tenth, it would be 19.2.